Hello. So today we're going to talk about quadrilateral. So what is quadrilateral? So qua means four, and then lateral means side. So this is very straightforward. It's a polygon with a two-dimensional polygon with two sides. We call it, this is a quadrilateral. So here is some examples of quadrilateral. These are all quadrilateral because they are all polygon formed by four sides. So one thing that you need to know about quadrilateral is the interior angles of a quadrilateral. The sum of interior angles of any quadrilateral is 360 degrees. So remember last time we talked about triangle. So the sum of the interior angles of any triangle is always 180 degrees. So for quadrilateral is 136 degrees. So here is some special cases of quadrilateral. One is parallelogram. So what is parallelogram? So parallelogram is a group of a quadrilateral have two pair of parallel side. In here, A, B, C, D. So for this example, we have side AB parallel to side CD and side AC parallel to side BD. So this is called quadrilateral. The opposite side and the opposite angles are concurrent. So that means the length of AB equals to the length of CD, and also the length of AC equals to the length of BD. Also with the hashtag, we know that hey, these two angles, they're equal. And then the other opposite pair of angles, they're also equal. This is parallelogram. And then rectangle. So this is something that we might really familiar with. So rectangle is two pair of parallel side, similar to parallelogram, and then four right angles. So that means these angles, they're all 19 degrees. All angles, they're concurrent because they all equal to 19 degrees, and the opposite side are parallel and also concurrent. Also, you need to know is a rectangle is a special parallelogram. Okay, so here is our square. Square is another special case of parallelogram. Also is a special type of a rectangle because every property that rectangle have, square will also have, such as two pair of parallel side and four right triangle. On top of that, in fact, it has four concurrent sides. So that means all sides and all angles, they are concurrent and parallel to each other. Okay, so the next one, another quadrilateral that you might see is called rhombus. Where's rhombus? So rhombus is look like this one. So four sides, they're concurrent, and then each pair of opposite sides are parallel. That make it another parallelogram. A rhombus is a special case of parallelogram. But a rhombus is not a square or a rectangle because it doesn't have a right triangle. But the opposite triangle, they're equals to each other. Oops. These two is equal. Four sides, they are all concurrent. So this is rhombus. They're not just parallel to each other, they also equals to each other. That means side AB equals to side BC equals to side CD, also equals to side AD. They're all concurrent. So another special case type of quadrilateral is called trapezoid. So trapezoid, the property has this property. Only one pair of the opposite side that are parallel is called trapezoid. So these two is parallel. Oh, this is not the parallel location, should be two arrows. So as long as in a quadrilateral, side 9WZ parallel to 9XY, we call this is trapezoid. You don't need to worry about whether the opposite angles are equal or congruent or not. As long as one pair of the opposite side are parallel, we call it trapezoid. Okay, so in the non-parallel side of trapezoid are congruent. The trapezoid is called isosceles trapezoid. That means if these two sides are equal and these two is parallel, so we call it isosceles trapezoid. Okay. So now which statement is true? Some trapezoid are parallelogram. Is that correct? So what is parallelogram? This is wrong because trapezoid have only one pair of parallel side and parallelogram have two pair of parallel side. So a trapezoid can never be a parallelogram. Parallelogram. Okay, all trapezoids are quadrilaterals. Yes, this is always true. Trapezoid is a special case of a quadrilateral. So all rectangles are square. This is wrong. But the opposite, all squares are rectangles. This is correct. This is true. This is true. Okay. D. A shape cannot be parallelogram and quadrilateral. This is wrong. If a shape is a parallelogram, then it is a quadrilateral. But sometimes some shape they are quadrilateral, but they're not parallelogram. A good example would be a trapezoid. Is a quadrilateral, but is not a parallelogram. Okay, so now here, the sum of a measure. So here is the graph. Let's say I have a graph look like this one. Oh my god, I can do better. This is P R X Q. Okay, so in this quadrilateral, we know that the measure of P is 60 degrees, and then the measure of S is 19 degrees. Now I want you to find the measure of angle Q. So because we know that, hey, the measure of the interior angles of a quadrilateral is 360 degrees, then we can use this formula, which is the sum of all this angle equals to 36 degrees, and then we use substitution and substitute the angles for R and X. So angle R is 19 degrees, angle X is a 19 degrees, another 19 degrees. Angle Q, we don't know. We leave it there. And angle P, from the graph, we know that it's 60 degrees. And then we use algebraic. We will find out that, hey, angle Q is equals to 120 degrees. Okay, so that's it for today. So today we learned some special cases, special types of quadrilateral, and also we know one property of quadrilateral is the sum of the measure of the interior angles of a quadrilateral is always 360 degrees. See you next time.